Hi, this is a video for grade 10. So we're going to look at some quadratic relations big picture questions. Here's the first question. It says a quadratic relation is graphed on the right. So there's our lovely looking parabola. Find the equation of the quadratic relation in both vertex form and in standard form. So I need to find the equation of that parabola. And the question asked me to find it in both vertex form and then in standard form. So the reason why I said and then in standard form is because we always want to find it in vertex form first, and then we can just algebraically turn that into standard form. So let's start by focusing on vertex form. Of course, to write something in vertex form, I need to find the vertex of the parabola. So I put a red dot at the vertex, and I can see that that's at the point 2, 5. So that's the vertex of the parabola, which means I can write a lot of the equation, but not all of it. So this is what the vertex form of a quadratic looks like. And the vertex is the part that fills out the h and k values. And because I have the vertex, I can write those numbers into the equation. So it's the a value that I don't know yet, and we'll look at how to find that in just a second. So let me just fix my pen here. So I get y equals a times x minus 2 squared, and then plus 5. So there's the vertex of that quadratic. Now I need to solve for a. So we know that a tells us the polarity of the function. Is it positive or negative? And it tells us the stretch factor. And I might be able to figure it out just by using the counting concept, but I'm going to try to do this one algebraically because algebraically will always work. So what I need to do is I need to find another nice point or lattice point on this parabola. So I'm going to use this point here because it looks like it's exactly at 3, 1. So every time you have a point on a relation, you have an x and a y value that you can use together in the equation of that relation. So I have an x and a y value in my equation. I'm hoping to find a. So I'm going to replace the x with 3 and the y with 1 because that's the x and y of that point. So I'm going to substitute 1 for y and 3 for x. And then what I have is the only thing I don't know, the only variable is a. So I now want to solve for a. So inside this bracket, I've got 3 subtract 2, which is 1. And then I've got 1 squared. So this is really a times 1 plus 5. So I have 1 equals a plus 5. I want to solve for a. So I'm just going to subtract 5 from both sides. So I've solved for a. And I can check on my graph to make sure that that makes sense. It certainly makes sense that a is negative because the parabola is a negative parabola, meaning that it is open down or the arrows would point down. And the fact that it's a stretch of 4, I can actually now confirm on my graph that if I start at the vertex, I go over 1, I'd go down 1, 2, 3, 4. So I guess I could have counted that and found that the stretch factor was 4, but it's nice to be able to back that up algebraically. So now I know my a value, which means I can write the quadratic that quadratic relation in vertex form. So a was that. I had a vertex of, hold on, 2 and positive 5. So that is the equation in vertex form. But now the question also says that I need to rewrite that into standard form. So standard form is where we expand this and collect like terms so it looks like y equals ax squared plus bx plus c. So that's what I'm looking for. That's what standard form looks like. So let's go ahead and do the algebra there. So I just have to basically expand and follow the rules of Bedmas. So Bedmas says, look in the bracket. Well, there's nothing I can do with x minus 2. So I did that. Then do the exponent. So let's square this binomial. So that's something we certainly practice a lot. It's where we started the whole unit. So if I square that binomial, oops, pen boo-boo. If I square that binomial, I will get what's called a perfect square trinomial. So I need to square the first, double the product. So the product would be negative 2x. And if I double that, I get negative 4x. And then I need to square the last, which would be 4. So I did the squared on that bracket. Now I can multiply, because multiply comes before add. So I'm going to multiply negative 4 by everything in that bracket. So I'm expanding negative 4 into the bracket. So I get negative 4x squared. Negative 4 times negative 4x is positive 16x. Negative 4 times positive 4 is negative 16. And now the only other thing I can do, or need to do, both, is to collect like terms, because at the end there I've got two constant values, values that don't have an x in them. Negative 16 plus 5 would be negative 11. That is the equation of the quadratic relation in standard form. Thanks for watching. Practice.